Welcome back to this TBO-1 repair, and we're going to look specifically at this potentiometer, which is part of the bias control. The actual parallel resistor had completely blown up, so I'm expecting this to be probably open circuit across where this parallel resistor was. So we're just going to, yep, that's open circuit, alright. So yeah, so this pot took a beating as well. So I thought I saw a crack on this resistor. I went to quickly measure it, and the whole thing just fell apart. So this is completely shot to bits. Yeah, so that's quite a high wattage resistor. I guess I'm going to have to disconnect this one and measure the resistance of this pot to give us an idea of what it is. And oh, it's just a 25 ohm. And I'll just quickly measure this. It should be a 39 ohm resistor, measures 45 ohms. And just for reference, I'm going to measure across the whole pot here, see what we get with that resistor measuring in parallel. And that's 16 ohms. That's good to know. And just to check, we're going to measure that again. Yeah, that was open circuit like we measured before. And now I'm going to measure across the other side of the pot. And yeah, that's all over the place. So this pot is completely broken both sides of the wiper. So unfortunately, this is actually riveted in. So I've got this replacement, which hopefully can take the higher wattage. I can't put it in this way, so I think I'm going to have to drill a hole so we can mount it and drill out these rivets. Give it to me. And I was lucky enough to find some new old stock P3139s. I think the originals are 1969 and these are 1976. And just as a sanity check, I'll just want to see what is actually connected to the case. Yeah, so this is why it's all shielded off. There's no earth connection to here, so this is all live. So we must do a post-mortem on this potentiometer. Look, you can see the coil track there. It's very much like my variac. And oh, it's starting to go a bit wonky. And yeah, this is where it's melted. Whoa. That is absolute toast. I wonder if I can get any picture of any plastic or melted bit. Oh yeah, there's some. Yeah, so this definitely took some wattage. Wow. There's some more burnt plastic down there. You don't really see many pots like this anymore. So this is the base amplifier, which is as it was. And this is now the rebuilt treble amplifier. I had to solder this leg to this transistor because the tab broke off. Not so great for the next guy, but it does make a really good connection, probably better than the socket. Now to power this thing up, I'm going to have to mimic the on-off switch, because the on-off switch is still in the Lowrey organ, and I realise that if I connect these two pins, it acts as it's switching it on. Okay, so we're going to power up. This multimeter is the AC input. This is 100 volt and this 60 volt. And I'm going to slowly bring the mains voltage up on the variac, and I'm connected to the light bulb meter as well. Everything's looking good. Get to 22 volts on the 60 volt rail, running at 90 volts AC, and the 100 volt is running at 37. Nothing is getting hot. Everything's looking good. Okay, let's take it up a bit more. So I'm looking at to get 30 volts on the 60 volt rail, which would be half its intended voltage, and that's at 126 volts AC. The 100 volt rail is at 52. Nothing's getting hot again still, which is good. Okay, that's looking really good, because those transistors will be conducting now. Okay, let's take her up. 35 volts on the 60 volt rail. Still no heat to be concerned about. We're at 142 volts AC. Okay, let's turn her up. Everything's looking really good. Almost at the top. 50 volts on the 60, 84 volts on the 100, and that mains input is at 208. Again, nothing's really getting hot. The power resistors are doing their thing. Yeah, I'm happy with that. Okay, let's take her fully up. And you can see we're at 237 volts. We're losing a few volts because of the light bulb. Nothing's getting warm. The 100 volts is at 92, and we're at like 55 volts for the 60 volt rail. So I've taken the variac out and the light bulb limiter, and look at that, the 100 volt is 100 volt and the 60 volt is 60 volt. Now that is excellent. And I've had this on now for about an hour and everything seems okay, although in the manual setup procedure it does say you need to do the biasing first, but the instructions don't match the actual topology of the amplifier that's in this circuit, so I'm not quite sure how I'm going to go about setting up the biasing. Yeah, that's the resistor that's getting hot, and we're pulling 65 watts at the moment. That's obviously off load. Yep, and we got our 60 volt rail there, which is really good. And the 100 volt rail, which is here. And that was the 10k resistor that also got blown. There's a 50 volt rail, which also feeds the amplifier section, which is great. What else do we have? There's a -7 volt rail, which is here, so that's good. And there's a -10 volt here on pin 2, which is measuring -12, 13. That's all off load, and this is an unregulated power supply. The -27 volts, that's looking good. And there's a 21 volt rail as well, which is measuring 22 volts there. That's down here. So that only leaves us now 3 more voltage rails to check. Well, 2 actually, because these 20 volts are joined together. And here you can see my setup. Lots of probes, lots of multimeters. It's insane. And I still could do 3 more multimeters. And there's my earthing scheme. Not the most elegant thing in the world. So I thought things were going a bit smoothly. This is the 15 volt rail. It's actually measuring 56 volts. That's here. It's very high. And if we measure the 20 volt rail, that's measuring 50 volts. So I'm not quite sure what's going on. There's no voltage dividers. I don't know whether this schematic is slightly wrong. There are a few differences that I found in the treble amplifier. Here you can see there's there's 4 transistors in this circuit, but actually in real life there's 1, 2, 3, there's one there, and then there's 2 more on this board, so that's actually 5 transistors. And if we check these resistors, so we have this 130 ohm, which is going to should be the 15 volt rail. That's this big power resistor here, and let's get good contact. 134, 135 ohms. So it all looks good. And coming off this connector here, first it hits this 500 ohm. Yep, 473. It's pretty close. And the other resistor around this area is this 25 ohm, which is this resistor here, measuring 27 ohms. So all those resistors match out. Not quite sure why the voltages are marked so different. And so the problem I got with the Lowrey repair procedures manual is, as you can see on their diagram, the 60 volts feeds both those transistors, so you can hook up your current meter and measure the current of those two transistors. But in this TBO-1 revision, you can see the 60 volts feeds the transistors in a completely different manner. I think we're just going to have to plug it in and have a look on the scope and see what we get. So let's see if this treble amp is working. I'm going to send a sine wave signal into the input here. This is the input socket. So I'm pushing my sine wave in there and monitoring the output. It's working. A little bit bouncy. I wonder if that's anything to do with the biasing control. Let's turn it up a bit. Oh, look at that, output is at 58 volts from a 3 volt input to 58 volt output. Very nice signal though. We're at 66 watts on the power. That's excellent. It's a bit wobbly. So I wonder if we can adjust the bias pot. Here's the pot I added. It's actually quite easy to access. I can focus the camera. So between these two pots, I don't really have any proper setup instructions, but it does seem to alter the shakiness of it. See there? I can make it stationary. So I don't really see much to complain about that. That's 64 watts now. Interesting. I guess we'll plug into the base input and output, and then we can judge. Yep, nothing's getting too hot. Right, so I'm plugged into the base amplifier now, and yeah, that's just as shaky. I wonder whether that resistor going out of spec has changed the bias at all. So I'm just going to have a little fiddle around, see if we can make that a bit more stable. Yeah, bias adjustment definitely has an effect on the wobbliness of that signal there. We need to remove the AC component. See, that's much better. And we're pulling 42 watts now. Interesting. So yeah, I think that bass section needed a little bias adjustment as well. That's looking good to me. And while I'm here, the mains plug is pretty unacceptable. You can see it's got wonky legs there. Terrible. And the pins are very oxidized. So we'll change this. So to recap, we had this leaky capacitor, and this whole treble amplifier secondary side had shorted out, and this 10k resistor had blown as well. This is the 100 volt well. Not sure if they're connected, but the 100 volt well sends signal to the photocells, so we're going to have to check those. Might not even get any sound if the photocells are broken. And the only other thing I need to do a bit more research on is this 15 volt well, which is measuring 56. The 60 volt well's fine, it's coming straight off this diode, and it's only going through a 130 ohm resistor, which I don't think it should drop down to 15 volts like that. The 20 volt is after this 50 volt, which is okay, and that's just going through a 500 ohm and measuring 50 volts. So I'm going to have to look into that.
Got some. Got some. Got some. Got some.